So in the last example, I sort of threw you in on the deep end and said, okay, here's the compiler explorer. You know, you can experiment with functions and understand how it works. What you probably need is actually to understand where does this come from, right? So clearly it's making choices about what registers go where. And you can actually find this with something called the calling convention. This is basically a detailed description of how arguments get passed down to a function, right? So when one function is calling another, how do those arguments get passed in memory or in registers or stuff like that? It varies both for architecture, so the type of microcontroller, and the compiler used. So I'm just going to actually pull up two AVR ones, not ARM ones. You can find them frequently in the compiler documentation, most of the time in them, right? So the functions themselves do a bunch of setup and just missing here, like teardown, I'm going to call it right now. But we'll look at that more when we get into the actual reverse engineering side of it itself. So we're not going to go too far into that right now. So as an example, AVR GCC. So AVR GCC is used by this is like the Arduino type, right, compiler. So the little Arduino with the AT Mega device uses AVR GCC. And you can see the calling convention. So this is copied from the user manual directly. So it's a little wordy, I know, but I kind of wanted to show you what it might look like. So, you know, it tells you arguments are allocated using some registers if possible. In this case, this is an 8-bit device, so there's sort of some more complicated than the previous one I showed you, where it was using it's a 32-bit device, so it's 32-bit registers, so it kind of everything always fits in a register most of the time. You could try passing a 64-bit and see what it does. But it basically tells you, you know, they start in even numbered registers. So if you pass a bunch of 8-bit, so KRs or something like that, what you're going to have is, you know, it's basically skipping a register, right? So they have one free register above them. And this is because, in this case, they have a move instruction, move word, that it's going to use by default. So by skipping it, it allows it to use that instruction. And beyond that, they're passed in the stack. So the other question is, how does it return stuff, which we didn't really look at in our exploration, right? So you can see that it's returning it. It basically has different assumptions about what registers it's going to use to return. So this looks different, right? So if we take the same AVR and we look at another thing, IAR, which is another compiler, what you can see is it's quite different, right? So it's basically incompatible, very directly anyway, with what the AVR GCC calling convention is, right? So we can see a few things, right? So you can see that it's saying, you know, if it's using 8-bit values, it actually doesn't do that skip a register thing, right? At least in this version of IAR. So this is a slightly older version I pulled this from. But you can see, you know, it's not doing that skip a register thing, and it's also using different registers. So you can see it's basically R16 to R23, whereas AVR GCC said it was happy to use R25 to R8. So what you kind of can see from this, the real point of it is that, you know, there isn't an answer for every calling convention. So if you start looking at, you know, if we're learning ARM, we're going to be looking at ARM with GCC. It's going to be different on a different architecture. It's going to be different on a different compiler. Potentially, if you go to like a really hugely different version of ARM GCC, it could change. They tend to not do that, though. So really where you're likely to see it is if you start looking at a different compiler or a different architecture. And it can be important for reverse engineering. So the interesting thing is it can actually tell you a little bit, if you don't know anything else, it can tell you pretty distinctly in some cases what compiler is used. So on the AVR example, right, this is pretty different, right? If you can look at some function calls, this is relatively obvious compared to this, especially with the different starting registers and also the skip a register thing or not. The function call recognition is pretty easy. So when you look at a function call, there's a few things here, right? So the return is typically pretty obvious. There's some either, in this case, it's using this branch to the link register. So this is called link register. This is kind of like a branch extended, this BX. You might also see ret. So ret is going to be very common in some architectures, which means return. So this tells us we're returning from some function call. We could either figure out how do we know this is a function. There are two ways. There'll be something called the prologue. So there's two things here, right? So I called this setup and teardown before, but in compiler language we call this the prologue, which is the start of the function doing any setup it's needed. We could also identify it potentially because we would see something that says like branch to square. Right, so we wouldn't know the name of it, but we'd have a memory address or something. At the end of it, so the actual end part here, right, where I was saying is returning, is going to be called the epilogue. So those are the two parts of the function setup. So the prologue sets everything up for us. We run our code, and then the epilogue does whatever other stuff is needed. Normally stuff would be putting return values on the stack, would be if we had to return. So if we used any registers, we want to return them to the state that they were in before. So we might return those registers back to the state and then jump back to whoever called us. So a lot of this stuff should have been covered in a computer architecture class. So we're not going to dig too far into it. But if you do need a refresher, there's a really good, so as part of the Azeria Labs post that I had linked to earlier, there's a really excellent tutorial on this. So if you weren't feeling too comfortable with it, I'd really recommend checking that out before going onward. So again, these are pretty fundamental parts, is recognizing functions and sort of getting used to the input and output. It gets a lot easier when we start opening some of this stuff in the tooling itself, because you'll sort of see quite a few of these. So that's one of the things that we're going to look at next, is sort of what are some of the binary formats that you'll use, and then we'll take a look at some of the tooling that you can use to analyze this.